Welcome to a lesson where you will find the distance between points using a graphical approach and also the distance formula. Let's get started. There's two examples on this slide, and to find the distance between the 2 points, we're talking about the 2 endpoints of this segment. It is 4 units long because you're counting the number of spaces. Whenever you're counting the number of spaces on a horizontal or a vertical segment, you can just start at one endpoint and count until you get to the other. I also could observe that this endpoint is 2 below the x-axis, and this endpoint is 6 above, and 2 plus 6 gives me 8 units. Now we have a sloped line segment. What we don't do with the sloped line segment is just count spaces. We only do that with horizontal or vertical. When we have a sloped segment and we're trying to find the distance between these 2 points, we could construct a right triangle. And we could measure the 2 legs because these are vertical and horizontal segments. So this is 5 units. This one here is 5 plus 7 or 12 units. And then we're trying to find the length of the hypotenuse, which is c in a squared plus b squared equals c squared. So now we will substitute in our values. I'll use 5, the smaller number, for a. I'll use 12 as b, and the c squared we'll just leave as c squared. Now we're going to square our legs. 5 squared is 25, 12 squared is 144, and we're still going to call this c squared. But let's add 25 plus 144 together. That's 169. So 169 is equal to c squared. And therefore, c is equal to the square root of 169. You can grab a calculator, and that's going to be 13. So that tells me that 5, 12, 13, these 3 numbers form a Pythagorean triple because they are the side lengths of a right triangle. All right, over here we have another right triangle that I've constructed to figure out the length right here between these 2 points. And again, we'll use the Pythagorean theorem. This leg is going to measure 2 units. This leg is 7 units. And we can substitute in our values for a and for b. And c squared we'll just leave as c squared. 2 squared is 4, 7 squared is 49, and this is going to be c squared. But we can add these together. 49 plus 4 is 53. So 53 is equal to c squared, therefore c is equal to the square root of 53. Now that's an irrational number. It is somewhere between, so 53 is not a perfect square, right? But it's between the perfect squares 49, which is 7 squared, and 64, which is 8 squared. This one is closer to 7. This number is bigger than 7. We can also use the distance formula to find the distance between 2 points with coordinates given. And the distance formula is subtract your x coordinates and square that, plus the difference of the y coordinates squared. So when we look at this segment, let's call this x sub 1. Let's call this y sub 1. This will be x sub 2, and we can call this y coordinate y sub 2. So we're going to subtract our x coordinates now. So that's going to be 5 minus 1. That difference is going to be squared. Now we'll subtract our y coordinates, 4 minus 1, and that's going to be squared. 5 minus 1 is 4. 4 minus 1 is 3. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25, and the square root of 25 is 5. Now I also could have looked at my right triangle and realized that, oh, this leg is 3, This is 4, and a lot of people know there's the 3, 4, 5 right triangle, which is a common Pythagorean triple. So that was another way we could have solved that problem. Now let's look at this problem, and let's substitute in our endpoints. But first, let's get the coordinates of the endpoints. So right here, this top endpoint is negative 5, 6. This is on the x-axis at 3, 0. Let's call this x sub 1 and y sub 1, and we'll call this x sub 2 and y sub 2. It does not matter which one you call the first point and which one you call the second point. You can decide that. So we're subtracting x2 minus x1. That's going to be 3 minus, now be careful here, we need that negative 5 with that x, plus y2 minus y1 squared. 3 minus negative 5 is the same thing as 3 plus 5, which is 8. And so this is going to be 8 squared. 0 minus 6 is negative 6, quantity squared. When I square 8, I get 64. Negative 6, when we square it, is 36. 64 plus 36, we're going to do that sum before we take the square root because there's understood to be parentheses here. This is going to be 100, and the square root of 100 is 10. So if I used the Pythagorean theorem approach, this would have been 6, this leg here, 3 plus 5, this would have been 8. And so we have a 6, 8, 10 Pythagorean triple where the length of the hypotenuse is 10 units.